So yesterday what we did was we created a table. Okay, we created a table first with a column family. Now in this table, in this column family, we keep on adding more and more and more and more column as and when we need. Just the way we keep adding the rows, we can keep adding the columns. Okay, so the behavior of adding the row and adding the column is exactly identical. All right, that is something very important. Like row has row key, similarly column has a column header. Column header can store some data, row key can store some data. So that's an important thing to understand, that you do while creating a table, you do not have to specify the name of the columns or data type of the columns. Okay, let me take up a specific example. So create a table C1 which has employee ID in C1 column family and name in C1 column family, and C2 which is an age. Okay, so let's try to create one. All right, so let's say we say create my table, and we say column family, we call it C1 and C2. All right, so this is the definition of creating my table, and let's call it okay, amp6 fab. Okay, now adding columns is as simple as this, saying put into this table for, let's say, the employee ID. We'll make the employee ID as the row key. Okay, let's just make this employee ID as row key. It's up to you whether you keep one more column for employee ID, which will be a duplicate information. Okay, so we'll just have name in C1 and age in C2. Okay, is that all right? So we could say easily like this: C1 name, and let's say the name is Leela. Okay, and we will say here employee ID is 1. All right, similarly we say put employee in this table, the row key, let's say second employee, and let's say it's a second employee, and then we can say, or you can actually remove even the single quote here. Okay, we can remove the single quote and say C2, or let's say C1, sorry, C2 age, and let's say the age is 34. Okay, or age is say, okay, now you can see that we are creating a table employee this one, and then putting some data into this. We are saying put into this table with this ID for this column this value. Similarly, same row key, different column family, and 30. If we had to create one more column in C1, let's say employee ID, name, and last name. Okay, last name, and we could have set this. All right, now let's try to run it. All right, and how do we run it? We open the console. Okay, here we go. Okay, now let's say HBase shell. All right, so what we can do now is, let's create the table first. Done. Then we add done, done, and done. Okay, now if you say list or scan, what is the table name? Okay, so you can see that for row 1, you have all the columns that you wanted. Let's have a look at what table we have just created. Okay, just give me a second and then I'll show you. All right, so this one is not working for some reason, and we could just click on this. And here, if we sort it by date, we'll get the table. So under the table, the first thing is the reason ID. Right now, there is only one reason server, one reason this thing. As you keep on increasing the size, more and more reasons will keep on appearing here. So this is auto-generated reason ID. Okay, so first a table is broken into reasons. Right now there is only one reason, and then after reasons there are folders like C1 and C2. See that? And let me try to flush. So I think the flush is okay. So I'm trying to flush so that anything which is in the memory gets cleared and put it to the disk. So you can see that under employee table, there is a reason ID, and under the reason ID, there is a column family. Under the column family is your actual file. So different column family, there will be different files in HDFS. Therefore, the data will be separated. So if the data is in different regions, then also it's going to be different files. If the data is in different column families, it's going to be in different files. Okay, so always you can visualize that your HBase table starts like this one, and then it starts like this one, where there are maybe, if there is C1 here and C2 here, there are two files and single reason. Okay, so table here, table here, and the moment we have more reasons coming in, both of these will get sliced like this. So there'll be four files, two for each reason. This is a reason 1, this is a reason 1 and reason 2. So as and when data keeps on increasing, these table will keep on splitting further and further. Okay, now as data in both of these increases further, this will split, and then after some time this, so not like this. So if the data increases in the reason 1, the reason 1 might also increase, also split horizontally, and then reason 2 might also split like this. Okay, so it'll keep on splitting further. And so now after there are four, how many reasons? 1, 2, 3, 4. There will be total 8 files. Okay, so these reasons are in reason server. Okay, so you can think of a table being splitted as if it's a big chocolate being splitted, and each piece of the chocolate is being distributed to different machine. So this basically this reason here, this is one reason. Okay, all right, that gets put on one reason server. Basically the reasons can keep on moving between the reason servers. Okay, let me do a quick recap. What happens is, so there is HBase server. HBase server is comprised of HBase master and reason servers. Okay, when you create a table in HBase, you are essentially creating a reason. Okay, and basically initially there is one reason dedicated to the whole table. As this table keep on increasing, this reason will split into two, like a fission reaction. And then and then if each of these individual reasons which are created recently, they will grow at their own path. And if any of them grow beyond a certain size, they will again break. And then these reasons can keep on moving between the reason servers. Okay, so that the load of storing, handling of individual reason is distributed well amongst multiple machines. Okay, and each reason is further splitted into column families. And then uh, so one reason is stored in multiple HDFS file, one file for each column family. Okay, so this is how the division is done. Now let's take an analogy of your table with a Oxford dictionary. Okay, so let's say you're storing, in a classic sense, you are storing key and value the way Oxford Dictionary has key, word, and meanings. Okay, and the data is ordered in exactly the way it is ordered in Oxford Dictionary. It's ordered by the key. In Oxford Dictionary, the word the dictionary is sorted by the word. Okay, so you can always think of your table as if it's a big Oxford dictionary in the HBase where there is a key and there is a value, and each page to be a reason. Okay, each page to be a reason. Just that Oxford dictionary has been created and is static, your table is increasing. So each page of the dictionary has got certain ranges, like from every page at the top says that this page includes words from here to there. In the similar fashion, every reason is defined by starting row key and the ending row key. All right, and these reasons or these reasons which are created out of the rows are divided are distributed to the reason servers. Okay, so if you have only three reason servers and you have 300 reasons, okay, so each reason server might get 100 reason each. Similarly, if you have, let's say you are trying to have a team of 15 people act like a dictionary, so and you want to build this really quick response system so that if somebody asks a word, you can answer it, give the meaning quickly. So what you do is you take three, let's say you take three people, you put them on the stage and give them one third dictionary, and you ask them, whenever somebody asks you a word, you route that query to these three people. That way you know clearly that from which word to which word is which with which person, and which word to which word is with the second one, and so on. Okay, so that's how it keeps on going. Let me just show you the diagram that will make you very clear. Okay, so you can think of, there are these three attendees, three people who you have nominated and given them various sections of the dictionary, and you are keeping track which section is with which person. Okay, so you are HBase master, and individual person is reason server, and the papers which you have given to individual is the reasons. Okay, so basically that's exactly the purpose of HBase. Okay, so what happens is that initially the whole table will be only having single reason. As in when you are adding more data to it, what will happen is this reason is growing, and the moment it grows beyond a certain size, it is split exactly into two halves, and two reasons are created. Okay, this is splitting of the reasons. Okay, so that was our recap of yesterday. We talked about data model, how to store and how to build one-to-many relationship, and the primary index you need to control in order to scan the data. Primary, as in row key, should be such that whatever data you need to scan through, the data should be ordered in a way such that the things you need to gather are stored in the nearby rows. Okay, so accordingly you will have to tweak your row key. All right, so we went through all of this. We were talking about MapReducer. So the in the similar fashion when we discussed in initial sessions, whereby we were churning the way we were churning the HDFS file through MapReduce, in the similar fashion you can churn HBase tables via MapReduce. Okay, in case of flat files, in case of HDFS file, what was happening is the definition of a record was being controlled by input data format. So in the case of our usual MapReduce, the row definition was governed by what is our input format. If our input format is text input format, then individual record that comes in is a line from your text file. Okay, here in HBase, by default, the input record is an individual row. It is an individual row from HBase table, and you write the map and you give out the key value in exactly the same fashion. Similarly, you create a reducer. Reducer will get the key and the array of values, and then it can write the output to the context exactly in the same fashion we did the MapReduce in our usual scenarios. So, and once you're done with creating the mapper and reducer, you can create a config object, and then you can launch the job by saying job.wait for completion. So you specify the mapping part, you specify the reducer part, and then you specify number of reducer, and then you wait for completion. Okay, there is no fixed order, as in you can specify this before table mapper, as long as the job object has been created before you operate upon job object. So first you create the job object out of the config, and then you specify all the parameters in the job. Okay, you create a new scan. New scan means what area of the table you want to scan. Okay, generally you can specify that you start at this row key and at this row key and so on, but here we are not specifying that. Okay, that's it. All right, so the next thing I would like to discuss is the Bloom filter. Although you would not require anything to do with Bloom filter, but since Bloom filter as a concept is asked by many people in the interviews, I would like to describe what is a Bloom filter. Okay, it's an important concept to know. Let's start with a small tale. So there was a person who was very busy. Let's call him A. He was very busy. Why? Too many people coming to him asking if their name, asking. So A is a watchman, okay, who is very busy because too many people are coming to him and asking if his name is in the register. So A is extremely busy in looking up the name of the person who are coming to A. Okay, so I mean millions of people are coming every day just to get their name checked. Okay, and this register here is huge. Okay, register here is has billions of entries. Okay, billions of entries. So every time this watchman gets saying that, hey, can you check my name in the register? He takes some 5 minutes to check in the register. Okay, and what he found that most of these people who come to him do not have the name in the register. Okay, so what he did was he suggested a plan to hire another watchman called first point of contact or bloom filter. So B is that watchman who is recently hired. Okay, and what he was given is, say, 4 letter word, 4 letters of each word in the big register. Okay, for only 4 letters of each word in the big register. That's it. Okay, so hardly how many entries? Anybody? So how many total 4 letter words are possible? 26 into 26 into 26. So only these many entries. All right. So what was done was, out of billions of entries in that big register, only first 4 letters were picked up, and new register was created and given to the watchman, newly hired watchman. Now this watchman's duty is to first, everybody comes to him first. In case their first 4 letters are matching, only then the checking is done by the main watchman in the register. Now what you see here is, since so the load of searching has been shared by the 2 watchmen. In case somebody's first 4 letters are matching, you can see that there is a duplicacy of effort. First B is searching and then A is searching, right? So similarly, this 4 letter of each word is a scheme. Okay, it's a scheme. It could be hash code. Okay, or you can say that pick up the alternate letters from the word and then pick up the alternate 4 letters, or you might say that just find the numeric value of every letter, sum it up and prepare a number. So basically a scheme which generates some kind of a code given to the second watchman, so that this newly hired watchman, who is the entry point, first entry point, gets a small register. Okay, he gets a very small register so that he can do the initial checking really fast. Okay, and when it's a time to do the thorough checking, then the main register is searched. Okay, so basically the what you see here is, when the data keeps on growing bigger and bigger, even the binary search as in, if you guys have used traditional registers, where the uh, in the library they keep a lot of cards stacked in big almirahs in alphabetic order. So there you keep on very quickly jumping to a particular letter and then keep on going further and further. So when even searching in a sorted list is also taking a lot of time, okay, then a scheme like a bloom filter is very much required. Okay, so this is a very important idea in the concept of any searching ways. So this watchman or the bloom filter which has been hired freshly, B, okay, is basically, when he says yes, okay, only then a watchman works in looking up his name. If he says no, then a watchman is not bothered at all. So B watchman, who is the first entry point, can give false positive, okay, which is validated by A. False positive as in, he says yes, but it's not always the case. Okay, now I want to show you this diagram. This will be more clear. So this is that B watchman, this is the A watchman. So first user comes in and says, hey, do you have key 1? This filter or the B watchman says no, then storage is not consulted at all. Okay, because if uh, if the code did not match, so it's 100% sure that it does not exist in the actual storage. Okay. Now, if another user comes in and says, hey, do you have key 2? And this Bloom filter says, yes, I do. Okay. Then the actual storage is consulted. Now, the actual storage might say yes or might say no. All right. So this is a Bloom filter. Now, how is it relevant in case of HBase? So, Bloom filter by default are defined by default in HBase, okay, and they are enabled per column family. So you can use H column descriptor and say set Bloom filter type to none, row, and row column. Okay, so by default they are enabled, and I think it's a row column. So on what basis the key of the Bloom filter gets generated? By default, it's based on all the values of row and column names, row key and column keys, and column family name. You can change it to consider only the row key, okay, and you can say none, which means there'll be no Bloom filter, and effectively your search will be little slower. Okay, so the Bloom filter is comes from a lot of actually statistically it's a statistically based data structure, and it comes after probably the name of a researcher. Okay, that's why it's called Bloom filter. Okay, because it's filtering lot of load which is reaching the main storage. That's why it's called Bloom. Okay, so you can take a look at more details at that place. All right. Now, sometimes you might want to process. Okay, idea is important than the code. So sometimes you want to do pre-processing or post-processing of the data that has come in. Okay, pre-processing as in you want to impose the security on a HBase table. Okay, so as the request come in, you want to check whether it's coming from the right user or not. If not, make it read only, give the error. And so we can create co-processors. The way every database has something called triggers that get triggered before I mean at various point of time. In the similar way, you have co-processors which get triggered at various point of time. Okay, so they get triggered either before and after, pre or post, and it can be pre-put, pre-get, and pre-delete. Okay, pre-put, pre-get, and pre-delete. Similarly, they can be executed post-put, post get, and post delete. So all you need to do is create your class which should extend the base region observer, and then you override the corresponding method. You don't need to override all of them. Whatever you want to alter the behavior, you can override that particular one. Let's say you want to put a security restriction that only few people should be allowed to read from this table. Okay, or you want to put a restriction like if somebody has come in to read a particular data, and if they are not from the admin group, you don't want to allow them. So that's pre-get. Or uh, there could be many cases for the pre-get. Okay, so you provide a co-processor environment and a get, and then if access is not allowed, then you throw an error and so on. Okay, let's say before the data gets put into the database, you want to throw an error if the data is not in a valid format. So you can override a method called preput. Similarly, if you don't want to allow user deleting the data, you can override pre-delete. Similarly, you can also do post-processing by overriding post-get and all. Now, once you have created this class, after compiling, what do you do with this? One, The other step is you copy it into the region server lib folder, and then you add it there HBase site.xml and mention its name in the in this property called coprocessor region classes. Here you add the name of your class as well. Okay. Now, but that would require you to restart the HBase master. Okay. Better thing would be that you put this into the table itself. You put the jar in, mention the jar into the table itself by using a path class and put the jar in the HDFS and mention that path here. And then you basically create a cell, create the cell in the table with the name as coprocessor $1 and the value as the actual full class name. Okay, so that way you will be able to put it in the table itself, and you don't have to restart the database, and it will load the logic from there. All right, you can make a call to HBase table using the REST interface. Okay, moving on. So you can access HBase from the web URL as well, so that you can, if even if the HBase server is hosted on our premises at CloudX Lab, you can use the same thing inside your JavaScript code. Okay, so you can basically invoke kind of, you can basically pull the data from HBase into your project using a REST call. REST call here is the grammar. Grammar means it says that the initial one is table. You can specify after that either the table name. Afterward, optionally, you can mention the row name. Sorry, you have to mention table name and the row name. Okay, you have to mention the table name slash row name slash. This rest is optional. Okay, this is optional. So basically that's little complex way to describe things, but it's quite obvious, so you can see that. Let me first start my REST server. How do you start a REST server? You can go here and say, you can give a different port, by the way. You can give a different port in the console, and your own personal REST server has been started. Okay, so my personal server has been started here. Similarly, now I can go here and say okay, which is the machine, e.cloudxlab.com. Okay, so e.cloudxlab, and so it says, all right, looks like it has been blocked. It says Jetty's outbound port is 8085. Is it so? Why? e.cloudxlab. No, it doesn't. So our Nginx is not allowing this particular connection. So let me first check. Okay, let me just. Okay, so we'll have to check, but the process is same. First, you start the server on a particular port, REST server, and then you can make a call to whatever data you want to call. Okay. So right, you can say here it will be e.cloudxlab, then the port number, the table name, the row ID, column ID, and so on. Okay, so this way you can access HBase via the browser. In case you want to access HBase via JDBC connector, which means from your usual Java code, you can use JDBC. Okay, you can use a project called Apache Phoenix, which is quite good when it comes to the accessing it in a relational, it kind of pretends that it's a relational database, or it kind of make it look like the traditional database. Okay, so that's pretty much with respect to the HBase.